We're on Western Lagrana, and this is an area where we've occasionally found quite spectacular samples of tin. I'm holding what we call Roberto's Rock, which was a boulder we found in the track here. Part of this assay, just over 20% tin. If you look in here, you'll see crystals of cassiterite. And one of the reasons why we drilled these two holes here was to see if we could find the source of this material. These holes have hit 1, 2, even 3% over a meter, 2 meters, but it's nothing in comparison to what we're finding in Oropesa. So we think this deposit is much smaller. It may not be as continuous what we're finding down in Oropesa, and Oropesa is our primary target. The mineralization that we know of, which exists today, stretches from that small dam over there to the other side of that field, which is a distance of just over 2 kilometers. So we look at this. The main mineralization can be found over a distance of about 1,300 meters. This, from our drilling, we know is approximately 200 meters. It may, I assume it'll get wider and thinner in various areas. Now, we don't know the dip on these faults. They're almost certainly won't be vertical. I suspect they dip to the south, so that means that these things will plunge down in this direction. So if you were thinking from a mining point of view, and you were going down a couple of hundred meters, if you went down 200 meters, your zone would be here. As to how deep these structures will go, we don't know yet. We think we're a long way from the granite source. I don't know whether the granite source is beneath us, whether it's over here, or whether it's over here, or whether it's here. We just don't know yet. To figure this all out is going to take a lot of drilling. One of the reasons why this thing was never discovered previously is that it is a complex ore body. It's complex in the fact that like many complex things, they're easy to understand in hindsight. While you're trying to figure it out, that's the difficult part. If this model proves correct, this is a relatively easy thing to determine. At either end of the 1,750 meter long Oropesa zone of mineralization, there are faults. We call them boundary faults. So we need to go either side of those boundary faults to see whether the mineralization continues on either side. To the west, we haven't looked there yet. We have no indications that the mineralization does continue. But to the east, it's a different matter. We have some pretty good stream sediment sampling. We've commented on that in a recent press release. We've also taken some grabs which are indicative, and we have some IP anomalies which need investigating. And hopefully it will continue for quite a distance to the east. And just to make sure that we have the entirety of this tin district, we've recently extended the size of the Oropesa investigation permits by acquiring 2 more investigation permits, which has over doubled the area of what we have.
It's still in the exploration phase, but the grades that we're getting are economic grades. The thicknesses are mineable. The issue is going to be putting together enough tons to make a long-term mining proposition. At the moment, that looks like that will occur, but there's a lot more drilling to do to confirm that.
We wouldn't have taken the decision to start drilling for resources unless we were confident that we had a very good chance of eventually disclosing something which was economic. The thicknesses of mineralization we've encountered in so many holes, the grades that we're encountering, are extremely unusual for tin. Our average true thickness is about 10 meters, and the grades looking like, on average, they're about 0.75, 0.8% tin. This is pretty special for hard rock tin deposits. Santa Maria is our second tin deposit in Spain. It is totally different from Oropesa. Oropesa is a hard rock deposit. Santa Maria is a colluvial alluvial. Colluvial basically means mudslide or avalanche. So if we go to Santa Maria, we find a thick sequence of colluvials, something in excess of 150 meters, We only know the thickness of colluvials on the eastern side of the colluvial deposit. It may be more than 150 metres. We still don't know exactly the number yet. We see a length of colluvials from one end to the other of approximately 3 kilometres. And the colluvials dip at about 25-30 degrees. The surface topography dips at about 10 degrees. And all indications that we have at the moment are pointing to an in situ grade somewhere in the 550 to 625 gram a tonne range. Now that compares very favourably with, say, what was mined in the past in Malaysia. So we feel confident that we have a potentially viable deposit in the colluvials at Santa Maria. But certainly we're looking at something which is about 3 kilometres long, appears to be about 60-70 metres thick, and hopefully will be at least 500 metres going down dip. Right now we're looking at stuff which is best defined as being indicative, but we're going to leave the definitive stuff for Santa Maria for a few months yet. Now the thing about Santa Maria which excites me is it's very clear that the amount of colluvials remaining is a very small percentage of what was originally there. We do know that about 12-15 million years ago there was a time when the Earth's crust tilted in that part of the that part of Spain. It tilted northwards about 30 degrees, and it was also a time when there were a lot of earthquakes. We are reasonably sure that the tin deposit at Santa Maria started off as an alluvial lake deposit. That we know where the source granite is and where the tin originally came from, and the tin from that appears to have collected in a lake. There was a process of winnowing which allowed the very fine-grained tin to be taken away by some sort of alluvial system, we don't know yet, and what was left was very coarse tin, which is great as far as recoveries are concerned. Coarse tin is very easy to recover. But if we look at the numbers, well, basically they look like telephone numbers. We estimate that the area that colluvials used to exist in was approximately 10 square kilometres. If we take the thickness that we have seen in the eastern part of the colluvials, 150 metres, that means something like 1.5 billion cubic metres of material has been eroded away. So where is that tin in that eroded material?